So let's continue with function handles. And so there's one other way to create functions in MATLAB, and usually used for very small functions like arithmetic or mathematical functions. So the way that works, basically you would have an anonymous function that would be function of a variable. So the way you can do that, I have an example here. For example, you say f is a variable of x, is a function of x, um, and you just like do that with this notation, this symbol at sign and bracket x, and then in front of it you can define the function. So here f of this is the same as saying f of x is equal to e to power negative 2x, exponential of negative 2x, and then you can give it a range to x, and f would change automatically. Okay, so now f of x is going to change according to x, and we'll talk about plots later on, but here you're plotting f of x with respect to x, and this is like what we end up with. Okay, you can also take, for example, integral of f. This is determined integral, so it goes from this range, finite integral from this range, from x changing from 0.2 to 0.8, and it would give you the answer. So like I'll talk about different functions as well. This is an example of integral function that you can take integral of a function from a certain point to another point. So this is about function handles. As I said, like it's usually used for very small mathematical functions like this. Or you can have an inline function. Again, similar to function handle, it is used for very small functions. So here you say, like, you define a function g is equal to a times x, where g is a multivariable function, right? It depends on a and x both. So this is the same as saying g of a comma x is equal to a times x. And later on, if you say g of 5 and 6, it would return 30. It would multiply them together. So that's another kind of functions you can have in MATLAB. So as an example, if you want to have function y equal to f1 of x, which y is equal to x plus 2 exponential negative x, you can define it like this, right? F0 would return the zero crossing of this function. This is another function that would give us another command that would give us the zero crossing of any function, and you can define it like this, or you can just like define another function of y. This is the name of the function. This is function of x. Y is a function of x, and it's defined like this. Again, why do we use dot star instead of a star? Because now if you do that, now x can be a vector. It doesn't have to be just one number. It can be a vector, and you can find like a vector of responses. Okay. Another function, f min bond, basically gives you the minimum of a function in a certain band, right? So like it would find the minimum of f2 between 0 and 5. So this is one of the examples of using function handles. What's the difference between, for example, this one? X is it goes from a range of 1 to 10 with the steps of 1. If you define f1, this is defining f1 as a function using a handle. This is a handle function. And this one is a vector. What's the difference? In this case, these two are the same. But if you change x from 1 to 10,000 with the steps of 1,000, f1 would change automatically with the new values of x, but f2 doesn't change because again, as I mentioned, the commands are going to be run from top to the bottom. So at this point, f2 is a vector that's, again, it's going to change from 1 to 10 because at this point when we defined f2, x was 1 to 10, right? So that's one of the differences between vectors and handle functions or function handles. Like it basically at this point, f2, it's just going to change from 1 to 10, while f1 it's going to change from 1 to 10,000. And you can see the difference. If I amplify this, you can see that here it goes all the way to 100, while this one goes to very large numbers. Okay, what is a toolbox? So MATLAB comes with many add-ons and many toolboxes that are used for specific applications. One of the toolboxes that is very commonly used is a symbolic toolbox. You can use it to solve equations, to find the answer, to take derivative, to take integral. If you install MATLAB, if you check symbolic toolbox, you would have the functionalities of these toolbox available to you. How you can use it, it basically use the sims command to define a symbol x. Now y, it's going to be x squared. If you differentiate y with respect to x, it would give you 2 times x, right? So everything is going to be symbolic parametric, and you can also find the limits. You can find different things. You can define a function with respect to 2 variables. So here we're basically saying that all of these are symbols, right? They're not going to be vectors, they're symbols, right? So and you can define them like this. So symbolic toolbox would give us another option to define function. For example, you can see here x is changing from 0 to 4 with the steps of 0.1. Y is x raised to power 2. Again, if there was no dot here, I couldn't do this because this is a piece, this is an element-wise operation. It's not a matrix operation. And then you can take derivative with respect to x. This is using vectors. You can also use the symbolic toolbox. So this is the same thing that we did over here using symbolic toolbox. This is using vectors. You can see that using vectors, we are giving values, but like using symbolic toolbox, everything is parametric. Now, as mentioned earlier, one of the advantages of using MATLAB, it's its visualization and plotting capabilities. So I'm going to talk about plotting, but again, in more recent versions of MATLAB, there are easier ways of plotting. What I do here is textual based plotting, basically like writing commands to plot something, while in newer versions of MATLAB you can actually plot much easier. But here I want you to learn things from scratch, right? So I'll focus on plotting using M-file or textual based, script based, I should say script based commands. So if you have a two-dimensional plot, you can basically plot something with respect to something else. Plot x and y means like plot y with respect to x. So the horizontal axis is going to be x, the vertical axis is going to be y, and you can define x here. For example, it goes from 0 to 6.28 with the steps of 0.01, and you plot y with respect to x. You can do that if you say plot x and y. You can also do three-dimensional plots using plot3. And I'll talk about mesh grid a little bit later, but mesh grid is something that you can use when you want to do 3D plots. It would create a surface of x and y. So here x changes from um, -2 to 2 with the steps of 0.2, and y changes the same way. So you create a 2D surface x and y, and now z is a function of x and y. So we're gonna have a three-dimensional space x and y, and z, which changes with x and y. Okay, and to plot it, you can use mesh or surf, and we're gonna see different 3D plots later on, but you can have two-dimensional plots and three-dimensional plots in MATLAB. You can plot multiple curves in the same window. This is something to compare different things together, compare different things with each other. If you want to plot multiple functions on the same window, you can use the hold on and hold off commands. Hold off, you don't need it that much, but hold on, you just like plot something, you hold on to it, and then you plot another thing in the same figure, in the same window. You can have different markers or different line styles. So for example, here, or different colors. So here I'm saying that plot y with respect to x with the color green. And here I'm saying that plot on the same window, on the same figure, plot v with respect to u with the color red. Use markers, circles, and the line style of dashed line style. So let's look at this example. So x is a vector changing from 0 to 10 with the steps of 0.1. Y is a function of x. Now you guys tell me, why do we have a dot here? Because if we don't have it, we get an error, right? Because this is a 1 by 100 or 101, 1 times 101, 1 times 101 matrix. The size of this matrix is one row and 101 columns. So you can't just multiply it by itself, but you can element-wise, you can do element-wise operation. For the numbers, for the scalars, we don't need to have dot, right? Because you just want to multiply this vector by a scalar. This is basically calculating the distance, right? This is like, for example, x plus 1 over 2a, which in this case is g times x squared, right? Time squared. So if you remember from physics, y is equal to x naught minus half of a t squared. So we're trying to plot y with respect to x, assuming x is time. This is two other vectors, xd, which again goes from 0 to 10, has 11 numbers, and yd is basically the displacement. We again like have the values. So here I'm plotting y with respect to x with the color green, plotting yd with respect to xd with color red, with markers O, with dashed line. You can add labels to x-axis or y-axis. You can give a title to your plot. Again, any string has to be within single quotations. You can add a legend. Legend means that I want to basically briefly introduce what are the plots that I'm plotting. So I'm saying that the first plot that I'm doing here, this one, is name it model. The second one, name it data. You can provide a range for your x-axis and y-axis. So here I'm saying that my x-axis goes from 0 to 11 and my y-axis goes from 0 to 600. So you can make your plot looking nicer, and you can also add any text that you want in the plot. You can provide the location, the coordinates for the text that you want to place, and this is the text that we want to do, comparison between two things. So this is what we end up with. It should be red. I don't know why it looks pink, but it should be red because we said red, right? And this is marker. Like when I was talking about marker, this is what it is. And this is a dashed line. This is the text that we placed. Like you see that it's at 1 and 100. This is the coordinate, and the text is here. The title, Y label, X label, and this is the legend. Okay, and you see that the x-axis goes from 0 to 11, the y-axis goes from 0 to 600. Instead of using colon, we can use linearly spaced. We're going to go from 0 to 4 pi, and we ask the linear space function to place 200 numbers between 0 and 4 pi. So this is basically the resolution. Y1 is a function of x. We want to plot it in color red. Hold on to it because we want to plot another function in the same window. Y2 is 2 times absolute value of cosine of x. Plot y2. Again, this hold on would make everything stay here. So y3 is going to be cosine. So basically what I'm saying, like, you don't need to add another hold on here. This would just like make everything stay on the same plot, on the same figure. Plot y3 with respect to x. Set the axis values, x-axis from 0 to 14, y-axis from -4 to -4 to 4. Add legend, and now you can say hold off if you want. And this is what we end up with. Okay. This doesn't look very nice, so it would have been better if we make the x-axis go all the way to 4 pi instead of going to 14, right? It would have been better if we make it nicer, but like doesn't matter. This is only for example and like for education. You can also have subplots. You can show multiple plots separately on the same window, on the same figure. What you need to do is basically first specify how many plots and in what configuration you want to have. So for example, here I'm saying that I'm going to have a subplot 3 by 2. Means that 3 plots, 3 rows of plots and 2 columns of plots. And you need to put subplot with the correct value whenever you want to plot on this specific spot. So if P is 1, it means that I want to plot over here. If P is 2, I want to plot here. If P is 3, I want to plot here, and so on. So let's look at this example. Again, x1 is linearly spaced between 1 to 20 with 100 data points between them. So the resolution is 100, like basically 20 divided by 100 is the step, almost. Y1 is sine of x1. Subplotted, we're going to have a subplot, 1 rows of plots, 3 columns of plot. And at this point, I want to plot on the first spot, which is going to be here. And I'm saying like plotted. So subplot is just basically a placeholder. Say like, okay, where do you want to plot it? And I plot it, I provide axis, text, and so on. I go to y2, and now I'm saying subplot 1, 3, and 2. So it means that the next plot, it's going to be plotted on the second spot, and so on. And finally, the last one, subplot 1, 3, and 3, it's going to plot it here. You can also have plots like this. Again, x1, y1, y2, y3 are 3 functions. Here I'm saying subplot 2 and 2 means I want to have 2 rows and 2 columns, but the first plot is going to take both the first spot and the third spot. So this is what I'm explaining here. 1 and 3 means that this is 1, 2, 3, and 4, right? So the first plot I want to have, it's going to take both first and third spot, plot y1, plot y2 in the second place, and plot y3 in the fourth place. Okay. Some of the data markers that we have available shown here. The line types that are available are shown here. Some of the colors that are available are shown here. If you want to learn more, you can use the help to get like more colors, more styles of lines, more data markers. It's better that you specify everything that you want to have in your plot in your script. But let's say that you plot something and then you want to change the x-axis, y-axis, you want to add title. There's a property editor. If you basically have your figure, if you have your cursor chosen, and if you double click on any of these spots on the x-axis on the plot, the property editor would pop up. You can change your x-axis, either the title, the range, the y-axis. You can change the font. You can change many different things. There's like many different annotations that you can change here. The thickness of the curves, the colors, and so on. Let's take a break here again. Sorry about that.